All right, we are in pre-AP calculus. This is notes 5.5. This is our second video. We're looking at an example of here's a function, and we need to find out all the important information about this function so that we can graph it accurately. What you see on the left is step by step how you could get from the beginning to the end. Essentially, there you can find the y-intercept from the original function and the horizontal asymptote or slant asymptote. And then the factored version is going to tell you where the holes, vertical asymptotes, and x-intercepts are. So it first asks, what's the equation of the function completely factored? So I'll tell you what this is, and then I'll explain how I got it. The numerator is going to factor into two binomials, 2x minus 1 and x plus 3. The denominator is going to factor into two binomials, x plus 1 and x plus 3. So how did I get the numerator? That's the part most people have some trouble with. If you have a trinomial, three terms is what that means, and the leading coefficient is not 1, in this case it's a 2, I believe splitting the middle term is the most effective way to factor. So to split the middle term, we need two things to get negative 6x, because that's what negative 6x squared. That's what 2x squared times negative 3 is. We need the same two things to add to get 5x. So that would be a plus 6x and a minus x. Let's just confirm that that's right. If you add those, you get 5x. If you multiply those, you get negative 6x squared. If you then group the first two terms together and the last two, and you find the GCF of each group, and then you think of this as one term, because it is. This is one term. What do each of those terms have in common? The x plus 3. If you factor the x plus 3 out to the front, then that's going to give you these two binomials, which is what we had up here. So let me get rid of this. And before I continue, let's just mark up this whole thing of everything that we know before we start answering these questions. For example, because these constants are negative 3 and 3, we're going to have a y-intercept of negative 1, because that's what negative 3 divided by 3 is. Because the degree of the numerator and denominator are the same, we're going to have a horizontal asymptote at y equals 2 over 1, which is 2. Because we have canceling factors in the numerator and denominator of an x plus 3, there's going to be a hole in the graph at x equals negative 3. Because we have a non-canceling factor in the denominator of an x plus 1, this graph is going to have a vertical asymptote at x equals negative 1. Because this function has a non-canceling factor in the numerator of 2x minus 1, this graph is going to have an x-intercept, a 0 if you will, at x equals positive 1/2. Let's answer the questions. If any exist, identify the vertical asymptote. Explain how you know there are vertical asymptotes. Please keep in mind on a test, this script's not going to be written here. I just wrote it here as a shell to save us a little bit of time in this video and in our notes in class. So vertical asymptotes happen from non-canceling factors in the denominator. This had a non-canceling factor of x plus 1. So we could say x plus 1 is a non-canceling factor in the numerator, and I probably should say which function, of f of x. Therefore, f of x has a vertical asymptote at x equals negative 1. Does the function have any holes? Explain why or why not. What are the coordinates of the holes? Holes come from canceling factors in the numerator and denominator. So in this case, we would say x plus 3 is a canceling factor in the numerator and denominator. Therefore, f of x has a hole at negative 3 something. To determine what the y value is, we're going to take our function, the factored canceled out version of our function. And we are going to replace x with -3. See what this simplifies to. In the numerator, we're going to have 2 times -3 is -6, minus 1 is -7. And a denominator, -3 plus 1 is -2. That's going to give us 7/2. So the coordinates of the hole we got here. If we answer all the questions, does it have any holes? Sure does. We said it has. Explain why or why not. That's our explanation here. What are the coordinates? We got that here as well. Going to continue to box in the equation. Pardon me, box in the question. So we know if we've answered all the questions. All right. If any exist, identify the horizontal asymptotes. Explain how you know they're horizontal asymptotes. So identify the horizontal asymptotes and explain. Well, the explanation is vertical asymptotes come from a non-canceling factor in the denominator. I'm sorry, we did vertical asymptote. I don't know what I said, but this says horizontal. Horizontal asymptotes come from the numerator and denominator, in this case having the same degree. Sometimes they have different degrees and there's a different interpretation, but in this case the numerator and denominator have the same degree. Therefore f of x, if it has the same degree, it has a horizontal asymptote at y equals, we take and we divide these coefficients. That's 2/1, which is 2. What are the zeros of the function? Well, the zeros come, it says show your work. Giving an explanation would be probably a better choice of words. So to show your work, my apologies for that. This comes from a non-canceling factor in the numerator. 2x plus 1 is a non-canceling factor in the numerator. Therefore, f of x has a 0 at whatever would make this equal to 0, which would be a positive 1/2 for x. And then finally, what's a domain and range? Give your answer in interval notation. The domain is going to be everything but where the x values are for the vertical asymptote in the hole. So the domain is going to be everything but -1 and -3. So we're going to go from -infinity to -3. We skip over -3 and we go to -1. We skip over -1 and we go to infinity. In layman's terms, this is everything but -3 and -1. As far as the range goes, the range is going to be everything but the y value of a hole and the y value of a horizontal asymptote. 2 comes before 7/2. 7/2 is 3.5. So we would say the range for this, we go from -infinity to 2. We skip over 2, go to 7/2. We skip over 7/2 and go to infinity. Now once you've graphed this, I would confirm that that's what's going on here. So let's take the information we have up there and let's put it in the graph. I highly recommend putting on the vertical asymptote, horizontal asymptote first. We said that we had a vertical asymptote at x equals -1. So that would be right here. We said that we had a horizontal asymptote at y equals 2. That would be right here. And then anything else I know, I'm going to add to this graph. Before I add those, let's label this vertical asymptote, x equals -1. Horizontal asymptote, y equals 2. We said there was a x-intercept at 1/2. We said there was a hole at -3 and 7/2, which would be right here. Those are the only points that we know. So the directions, which I should have read before I started doing that, sketch a detailed graph of the function on the grid to the right. You will need to use a minimum of 8 points, 4 for each branch. Well, these asymptotes break it into, there's a part of the graph here and there's a part of the graph here. So this is a branch and this is a branch. So let's see, we didn't put the y-intercept on that. That's another point that we have. We have the y-intercept we said was -1. I forgot about that little fella. So on this branch, we already have 2 numbers. We have 2 ordered pairs. We need 2 more. On this branch, we only have 1. That's the location of the hole. I'm going to make a little table. X on the left, and then the function on the right. The function is 2x minus 1 over x plus 1. So for example, let's say that we want to know what's happening here at 1. What's the y value going to be? If I put 1 in, if I put 1 into this, 2 times 1 is 2, 2 minus 1 is 1. If I put 1 in the bottom, I'm going to get 1 plus 1 is 2, that's going to be 1/2. So at 1, we're going to have a point and 1/2. Let's go to 2. If I put a 2 into the top, that's going to be 4 minus 1 is 3. 2 in the bottom, 2 plus 1 is 3. 3 divided by 3 is 1. There's a point here at 2, 1. So we just need a minimum of 4 points on each branch. I'm just going to try to connect those. Hopefully that's enough to give me an idea what this graph looks like. It looks something like this. And I guess I don't want that to just auto. It gets closer to the horizontal asymptote and vertical asymptote as it continues and doesn't cross them. In some cases, you can pass a horizontal asymptote. You can never pass a vertical one. So let's check out. So that's 4 points on this branch. I only got 1 on this one. Let's find some others. Let's say that we chose, see what's happening at -2. 2 times -2 is -4, minus 1 is -5. -2 plus 1 is -1. -5 over -1, that's +5. So at -2, 5, we have a dot. Let's check out -4. On the top, it's going to be -9. On the bottom, that's going to be -3. So we're going to have a point at -4, +3. Let's say that I went with a -5. 2 times -5 is -10, minus 1 is -11. On the bottom, -5 plus 1 is -4. So that's about 2.75. So that would look something like this. So that concludes that example. This is important so you can know what the graph's going to kind of look like. I will stop this video and make another for the last example.